In your first lesson, you were taught how to simplify a square root. Square roots are basically numbers that can be written in pairs because they form a square. And remember, a pair is just a number times itself. So for instance, the square root of 9, which is visually shown here, can be written as a pair of 3s. And it's based off the dimensions where you look at this right here is 3, and this right here is also 3. Or this can be written as the square root of 3 times 3. The square root of 36 can be written like this, where it's shown here. Here is 6, and here is 6. This can be written as the square root of 6 times 6. And when you get these pairs, they ended up canceling each other out, and you're left with just one from the pair. And so the one that's left from the pair goes in front of the square root, and you're left with just the square root of 9 is equal to 3 here. 6 times 6, again, one from the pair comes out, and you're left with 6 times 6, or square root of 6 times 6 is 36, or the square root of 36 is 6. Now, what happens when we don't have nice numbers like that? For instance, let's look at the square root of 20. Well, if you write the factors of 20, you get the square root of, for instance, you can have 4 times 5. Now, we can rewrite this by looking at what we call prime numbers. And brief review of primes. A prime is a number where the only factors are 1 in itself. So the smallest prime we have is the number 2, because the factors of 2 are the numbers 1 and 2. 3 is a prime because the only factors are 1 and 3. 5 is a prime because the only factors are 1 and 5. 11 is prime because the only factors are 1 and 11. 17 is prime because the only factors are 1 and 17. So from this we can see that the only factors are going to be 1 and 17. We want to try to write all of our square roots in terms of their primes. So take the number 20, and we already said the factors are 4 and 5. And what we're going to do here is we're going to break these down to their primes. The question I want to know is the number 4 prime? And the answer there is no, because 4 has factors that are 2 and 2. Is the number 5 prime? 5 is prime because its only factors are, over here, 1 and 5. I'm going to go ahead and circle this number because it's a prime, and that means I can stop dealing with it. Now, I've broken 4 down to 2 and 2. Is the number 2 prime? Well, over here I see that it is prime. So both these 2's are prime, which means that the square root of 20 is also equal to the square root of 2 times 2 times 5. And again, I'm looking for pairs. Do I have any pairs here? I have a pair of 2's. Because I have a pair of 2's, one from the front, one from the pair comes to the front, and whatever's left underneath will stay here. So I get 2 times the square root of 5. And this is what we call the simplified. This is simplified square root. Let's do one more. Let's look at the square root of 48. First thing I need to do is find factors of 48. So the factors of 48 are the numbers 6 and 8. And the question I want to know, are the numbers 6 and 8 prime? Well, the factors of 6 are 2 and 3. And the factors of 8 are 2 and 4. Are either of these or any of these prime? Well, 6, 2, and 3 are both prime. And in 8, 2 is prime, but 4 isn't. So from here, we go to 2 and 2. So these 2's are now prime, and we can rewrite the factors of 48 as all the circled numbers. So the square root of 48 can also be written as 2 times 3 times 2 times 2 times 2. And generally speaking, we write them in order. So I'll write this as 2 times 2 times 2 times 2. I have 4 2's times 3. Do I have pairs? I have this pair of 2's here and this pair of 2's here. One pair comes to the front. One pair from this set of 2's, from the other set of 2 comes to the front, and we multiply them. And I leave whatever's left underneath. So now I get 2 times 2 is 4, and this is equal to 4 square roots of 3.